Hello, this is the recording of chapter 5 in the course note, and I'm going to talk about platforms and tools, network management platforms and tools. So, we talked about several aspects of network management, and in this presentation, I'm going to talk about some of the most common tools um, that we need. And actually, some of these tools are defined in RFC. It has been around for a long time, and the request for comment talk about some of the tools that we can use for network management and monitoring. And actually, it focuses more on the monitoring side, and we'll talk later about some of the management tools that we have, specifically the ones that are open source. Right. So the RFC talks about four of these tools, and I added the fifth here, which is the traffic generation. So some of them you're familiar with. So we'll classify them into 5 categories. The first one is the status monitoring tools, and these are monitor the status of a node, right? And sometimes a link, right? So we have them specifically to find out um, the condition of nodes. And one of these, at the top of these tools, is ping. So when I ping a device, I know if it's active or not, or at least if the part of the protocol is active or not, right? Because when I ping, the response, well, I send echo, and the response will be echo reply. That part, I know that it's working. A device could be a complex, a server, for example, or a router. Maybe some aspects of that router is not working, right? But at least I know that it's responding to ping, and it's powered, because if it's not powered, it won't be replying. Uh, Another common uh, tool is the ifconfig or ipconfig, ifconfig in Linux and ipconfig in Windows. And these tools give you the status of the interface, right? So if it's up and down, if it's the MAC address, the IP address, the IP version 4, IP version 6, and so on. Right? So uh, these are now, the IF config is considered outdated, and the replacement is the IP command in Linux. So if you go and, so we have in Linux, we have the fconfig, and we also in recent distributions, we have the IP command. The IP command, you can add IP link. It will give you the link, the interface status, and the IP address. For example, it will give you the addresses. And I may show you examples while I'm talking here. So, for example, if I, let's say, make this a little bit bigger. So if I do IP link, it will give me the status of the links, and this is one of the nodes that I have, and it gives you the name of the links or the interfaces and the MAC address for the interface. If I do IP address, it gives me the IP address. In this case, IP version 6 or IP version 4. The ifconfig is no longer working for this, so you have to download it as a separate tool if you still want the ifconfig. And you will notice in the labs we will use the previous forms to IP link and IP address. Right? And this is actually much richer command. It gives you a lot of options. You can set also the not you can set IP address, and you can set default gateway, and you can use it to find out um, the routing table for a Linux device and other things as well. And you can see there's statistics. Let's see if I do IP link and -s. Yeah, we may have usually there is the completion of the device of the information there. But anyways, so the purpose of this lecture is not a demo, so I'm gonna skip through all the details. But as I mentioned in other classes, when we do ping, we can also find out a lot of details about, for example, the TTL, the round trip, and I also know that the destination is active, right? So these are ping and the IP command. So the IP command or the ifconfig and ipconfig are the old ones. The IP command is the new one. NS lookup looks for or troubleshoots the DNS server. So I can, for example, find out if the DNS server exists, or gives me information about the DNS server. When I do, let me switch. So if I do ns lookup del.ca, it gives me the address of that device, del.ca, and also tells me about my own server, right, which responded to the DNS. Dig is similar. It gives me this similar information. Host displays information on internet hosts domains. Let's see if I can have it here. So the three tools actually, they do similar job. They give me information about DNS. All right, so traffic monitoring tools are dedicated to testing traffic or testing the status of a link. Ping is same thing as before, because as I just showed you, you can ping a device to find if the device is active or not, but in the meantime it does give you statistics about the link itself. For example, the round trip, right? Bing with a B does similar job, although it's less famous, and I don't know if it comes by default. It doesn't come by default in Linux boxes, so it's I cannot show it here, but it does similar thing. You're familiar with TCP dump and Wireshark, and there's also T-Shark. So these are turn your node into sniffer, and it will capture all the traffic that comes to the interface. So I think I have T-Shark here, so we'll try T-Shark because it's not mentioned. So if I do T-Shark, no, I don't have it. All right, TCP. T-Shark is the command line version of the Wireshark. So if you are in a situation where you're dealing with a server that doesn't have a GUI, use T-Shark instead of Wireshark. TCP dump, I think you just need to mention the interface and use sudo and it will capture all the traffic, the packets that come into that interface. You can filter the traffic so that you get only the protocol that you're looking for or the address that you're looking for, so instead of capturing everything, right? This TCP dump can be or has been around for a long time. Wireshark is common, as well as T-Shark. You can download Wireshark and T-Shark will come with it. Or you can download T-Shark by itself. The third set of tools is the network routing tools. These are different tools that allow you to test routing functionalities. So I don't remember all the command line options here, so I'm gonna try and do the help and see what I can get. Stat, maybe I don't have it. All right, ARP, well, that's easy. So with ARP, again, so these are, it says install net tools. These are old tools. They don't come with Linux boxes by default nowadays. So you actually can get the same functionality using the IP tool. So ARP, I think it says neighbors. You can get ARP neighbors, IP neighbors. It will give you the same effect as ARP. So let me check here. Yes, if I do ARP NEIGH, it will give me the ARP table. This is the equivalent to the command ARP. Okay. And okay, trace route, also an outdated command. Just it's mentioned in the RFC, but the equivalent. So if I do trace route here to del.ca, it will not. Yeah, it won't work. But if I do the equivalent, which is, or the newer version, which is mtrdel.ca, it will give me this nice interactive view, and it will give me all, it's like exactly works like trace route, so it will give me all the routers in between, right? And it will give me the status of the link for each one. So from my node to the main gate, which is my main gateway, it will give me statistics about how many packets sent, the ping. Actually it uses ICMP echo. It gives me the delay on each one of them, and the loss. You'll see here there is certain loss in one of the links, and I can change the display, or anyway, a lot of options. So I mentioned MTR here. The root in your Windows, you can write root directly. In Linux, you can write IP root, and that will give you the routing table. Okay. And here, default via 192.168.2.1, and the link is ENP2S0. So that's the next, that's the gateway, and this is the next hub, and this is the interface, and this is a static route, right? While this is learned. SNMP tools are tools that use to send and receive SNMP messages. So they are equivalent. There are a tool for each one of these messages that we talked about in previous classes. One of them is common, which is the SNMP walk, which gives you the tree, right? And we did that, and there is a demo also. So if I do SNMP walk and give the community string, well, first of all, we'll give the version that we need to, version 2C, SNMP version 2, and then the community string, which I think it's something like this. And then the destination. This is the device that I want to get SNMP information from. And then the root of the tree that I want to grab, right? So what happens is SNMP walk sends get next request and keeps sending get next request until the entire tree is retrieved. And you can see here, this is the node and the type, and then the value. The value here is not there. Here's the node name, ID, and the type and the content. Okay. Some of them are empty. See here, there are empty, there is nothing. Actually, you're not seeing anything, sorry. Let me go back. I think I missed the... so let me repeat that because I didn't show you. So SNMP walk -v, that the version -c is the community string, and then the destination, and then the top of the tree. And when I hit, so SNMP walk will go and grab all the information in the tree until the tree is over, right? And as I was saying, so this is the object ID, this is the type of the object, and the content. Some of the content is empty, so I don't have contact information here, and I don't have location. This is read-write object IDs, and the administrator sometimes they don't put the information, so what you get is an empty string, right? But some of them are put there by the system itself. So this is usually defined by the manufacturer, the object ID of this particular device. The system uptime also, usually it's read only, and it's provided. Here, system name can be entered by the administrator. Number of services for this device. So this comes, it doesn't matter what it is, but it comes with the interface, with the tree. I mean, if I want to look for another tree, Then this is the interfaces tree, and it will give me information about all the interfaces. Right? So a trap will send a trap. So this is good if you want to test your network management system. You don't have to create a problem in the network for the network to generate a trap. You can use this tool to generate a trap and test your uh, system. Finally, traffic generation tools. These are traffic generators. So we use ping a lot, but ping sometimes is just one protocol, right? What if I want to generate TCP traffic? What if I want to generate UDP traffic? What if I want to generate a large volume of traffic here? So I need to rely on some traffic generation tools. There's a lot of these tools available. I put here the ones that I know they are open source, so you can download them and use them. One famous one in particular is the iPerf. There is iPerf. I don't know how it's pronounced correctly, but iPerf, the original, and iPerf 3, which is not really compatible with it. There are two different systems. And the way I work it, if I have it here, is to create a server and a client. So let's say I want to generate traffic between two different devices. So I can go to one device and run iPerf as a server. And the way I do that is by, let's say, go to the destination, the server, and do IP or iPerf-S. So that will turn the device into a server listening for traffic. And then go to another device and put the destination and -C, which means this is a client, and then a bunch of other information, and that will generate traffic between the two systems, right? And I can specify TCP or UDP. I can specify which ports I can test, and so on and so forth. So that's good for generating traffic. Packeth is another one that actually gives me user interface and let me design my own packets, right? So I can, let's say I'm testing a specific protocol, a new protocol. So I can specify the content of that protocol and send packets. So it gives me a lot of flexibilities here. Anyway, so that's a lot of traffic generation tools for testing. So if you combine all of these, you will have a good set of tools for doing network monitoring or troubleshooting. So, for example, you can run ping. If you can run a script, or you can write a script to run ping continuously. So it discovers the entire network on a regular basis. And if a ping does not reply, then it can send you an alert. It says, well, that device is not responding, so you can react by checking. You can test links, and you can monitor the link statistics over time. And if you notice there's a delay increasing in one of the links, you can also go and check SNMP tools, you can use them on regular basis to grab SNMP information. So you can build actually a network management system using these specific tools, especially if you are good with writing shell scripts on Linux, or if you use Python as well, and then Python can call these tools. So a lot of tools that you can use either for troubleshooting, which is every once in a while, or you can use them as part of a bigger network management system. So, and this is how actually network management platforms are built. Most of them that I know of, they are actually made of several smaller components, and each component will do something different. One of them we will see in the lab called Observium. It's actually, when you look at the details, you will see that it's made of PHP scripts, and the PHP scripts do a lot of these ping for testing the connection or discovering the network, uh, for they do polling, which calls SNMP tools to grab information from devices using SNMP and so on. So you can use these specific smaller components to build a network management platform. But the network management platform in general is the software system that does or integrate all of these management functions, all the FCAPs, right? So you can build, or you can have a software that does configuration management, performance management, fault management, security, and accounting, all in one platform. Some of them are dedicated only to one function only. So you can buy um, software that does only network discovery, right? Not even full configuration management, but only part of it. So it is really up to you. Once you know what is needed, it's up to you to collect the 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 tools that you need to perform effective network management. And you don't have to, um, when we do monitoring, we don't have to monitor every piece, everything. When we do management, we don't have to. What I'm trying to say is, the amount of network management and monitoring that you need is really depends on the size of the network and how important certain aspects of the network are. Okay, so I'll visit this point as we speak. So the platform consists of several components, usually built around or being modular. So some network platforms, they don't come as one piece of software, they come as different pieces of software. Each one of them is dedicated to one task, right? And most importantly, they rely on network management protocols. So the piece of software that you need, that you use, it may rely on underlying protocol like SNMP or ICMP, right, to do network management. So what are the main components? If we look at um, all of these components here, they actually correspond to what we talked about in previous lectures. So if you look at, let's say we have, this is um, this is our platform piece of software. So this is our, what we refer to as our network management system. our network management system may rely on network management protocols to talk to managed elements. So you may need SNMP, you may need ICMP, you may need others, right? And the network management system may consist of multiple applications. So one application does, for example, configuration backup. Another application or another module does network discovery. Another module may do performance management or performance monitoring. In all of this, we need to, let's say, need a database to save all of this information. So if I use SNMP, for example, SNMP does not save historical information. So I may need to use SNMP polling to grab the information and then save it in a database. So when I do performance management, I can draw a graph. For this to work, sometimes I need to have, not sometimes, but often, I need to have a GUI, a graphical user interface, or sometimes the command line would be used as well. And finally, I need to have some kind of a security, right, or access restrictions, because network management will allow me to configure the network, change everything. So I need to have some form of restrictions, authentications. I may also, if I want to use SNMP, I may also need to have some way to import MIBs, and I'll explain why we need that in a minute. So you'll see here some of the components: reporting, MIB import, network management tools. Like I can some of the components is or allows me to log in to devices. So telnet may be built in the network management platform. Auto discovery, auto topology, all of that can be several components that can fit database management system using relational database or other forms of database is needed. So all of this fits inside a network management platform. Why do I need MIB import? Remember, there is the MIB standard MIB that all devices support. But if my platform, I buy something or I install something open source, but I need to manage devices from a specific vendor that uses its own MIB or its own MIB tree in addition to the standard MIB tree. So I need for my platform to understand what that MIB is, right? So usually the MIB devices or the MIB comes as a text file that I can import. So I may see here something that, let me see if I can show you an example. So here, if I want to download some MEB files from Fortinet, for example, I can go to Fortinet site and download the MEB information. And then I can take this text and upload it to my network management system. Okay. So how about functionality? So platforms comes in all shapes and sizes, and as I said, some of them are really huge and they cost tens of thousands of dollars and they do every aspect of network management. Some of them are simple, right? So, for example, some of the tools that I have can do only one aspect, which is scanning. So if I can show you here, a tool that does only network scanning using SNMP. So here I can scan my network. And what the tool does is just go and ping the entire range from 1 to 254 and comes back with all the devices in the network. So this can be just one part of bigger network management platform that I have, right? This isn't free, you can download it. Or there are other things, for example, Putty is another example of a tool that allows you to log into devices, right? So there is a lot of these components that you can use for only limited functionalities. There are others that can do a lot more. Okay. So there's a lot of things that I can show you here as for demonstration, but we'll just go over the overall picture first. So we can have event logging, we can have performance, we can have topology management. All of these are part of functionalities that we have. All of these can be different components. So let's go and talk about something that's more specific. So I may show you here some demos. So this is what we will use in the lab. It's called Observium. It's open source. And this is not a complete network management platform. It's actually very limited, but we use it because it has some nice aspects. One of them is, if you want to describe this, you will say that it's mostly focused on performance management, right? And actually, it does mostly rely on SNMP to grab information. So if I want to go, let's say I have 7 devices here that are managed. If I look at one of them, which is the main gateway, right, you'll see here that I can look at traffic in different ports, and it will show me the bandwidth. here I can see the device availability, so it's 100% means that it has been on for a long time, right? And if you look at different devices will show you different information, but if I look at the ports, you will see here this is the bandwidth consumption within 1 day or within 1 month or 3 months for however this been used. And you can see, for example, the trend here, right? We talked about trends in previous lectures, so you'll see how this is. There are certain, it's called an anomalies. There's maybe not something that was downloaded a lot that day, uh, but in general you can see the trend here of using this. I can monitor printer, for example, so the printer bandwidth may not be the biggest thing that I care about, but the ink or the toner information is important. So we have here uh, different colors with different percentages of what's left. I can monitor the health. So this is the CPU for different devices. So right now the CPU usage is 10% in one device, 22% in other devices, 40% in another, and so on. Right? So in this particular network management system, the CPU is high. So maybe the system needs to be upgraded somehow. Memory, storage. So if this is mostly for performance management. I can also look for syslog information, and I can create alerts. So I don't have alerts here, but I can generate alerts. We talked about performance management and the importance of alert. So I can create alert for different thresholds. So there is a syslog rule or different rules. So I may say every time you get warning message from syslog, you can send me information. Here there is contact information. Or I can create alerts for um, different different thresholds. And so every time the bandwidth increases over a certain limit, I can send a threshold. So this tool, Observium here, does a lot of tasks related to performance management. It's almost dedicated to performance management. It doesn't do much about configuration management. So it doesn't deal with configuration, it doesn't do backups, it doesn't do topology discovery. It does limited topology discovery. We'll see it in the lab by telling uh, the the tool which subnet or subnets you wanted to discover. So it goes and scans them and comes back and tells you here's the devices that were scanned. So it has some limited discovery. It doesn't have any mapping. It doesn't show you the map, doesn't show you the connections between these devices. If you look at the maps, here are all the maps that the software can understand. So some of them are proprietary maps that were uploaded or downloaded for this device. You can disable the ones that you don't need or enable more. You can also import some, I guess. So for for a small network, that if you need a performance management tool, will be good. And I use it here mostly for demonstration, but sometimes it gives me a good indication about the status of my network as well. Right? It can also go to the hypervisors and tell me about all the um, all the virtual machines and which one are active and which one are powered off right now. So it tells me a lot of information. Another tool, um, it's not really network management tool, but you can, I mean, it's not designed just to be a network management tool, but you can use it um, for that purpose. So this is called INWK6912. It's a time series database and it has a user interface. And uh, it can be used for dealing with SNMP information. So it works like a performance management and it gives you the um, statistics about, or give you similar to the previous tool, gives you bandwidth consumption on certain interfaces. You can also use it for different protocols altogether. So here there are some environmental sensors that send information using um, the protocol specific to this database, and it is saved here in the database, and I can see it. And you can see here, for example, temperature from different kind of sensors, um, and actually three kinds of sensors. So one type of sensor here sends information using Wi-Fi. This is another set of sensors that uses information uh, or sends information using Z-Wave, and this is another one using Wi-Fi as well. And all this information is collected in the database and I can show it. So this, I can build network management system using such tools. Any tool that can allows me to uh, monitor my network will be fine. I can also add thresholds and add alerts to this. You can see here, you can design your own alerts. So every time there is a performance management aspect, there are alerts that you can use to to let you find out if something wrong is happening or out of the ordinary. There are other tools that I don't have is device inventory manager, which you can actually build yourself by going onto each one of these devices and grab the configuration and save it on a regular basis. We can do that using Ansible, which I'll talk about at the end. You can, there is trouble ticket management systems that can be involved as well, trend analysis, performance analysis, so you can take this data and show it. There is also something interesting that I always show here. Um, I just need to remember the URL for it. Let's give, so here, let me see. One aspect of network management is related to visualization, as I mentioned in previous, and this is one of the examples that are interesting. So we have a network called the Canary Network in Canada, and it's a fiber network that connects a lot of sites across the country, from Vancouver to the far left here, far west, to St. John's in the far right. Here is Halifax. This is actually Dalhousie University here, and it has connection, right? So in this map, I can see the status of the network visually, right? And the colors represent different traffic loads. If I go to any particular link, and I can see the traffic, the IP traffic in that link, right? I can see here the black links have very low traffic going through, or sometimes zero altogether. The ones that are close to red here are really busy. So we have almost gigs of traffic. So the cooler the colors, the less traffic, the hotter the colors, there are more traffic in them. And I can see the status of the network visually, right? So this is could be one of the components that you use in network management. Imagine you are in a network operations center and you have this map displayed on a big screen, and by looking at the map you'll know what's happening in the network at any given time, right? So that will give you the status of the network in the entire country almost. So from Vancouver, Calgary, Winnipeg, Toronto, Montreal, Halifax, St. John, Moncton, Edmonton, almost every province that we have, Ottawa here, and it will show you the traffic in the network. Okay, so this is the tool itself is open source. It needs a little bit of configuration, but it is open source network, open source tool. Right. So we'll talk about scale. Scale, it goes from the very small tool that I showed you that does only scan, ping, from a maybe medium scale or even smaller, considered small scale like Observium, to really large, very large scale that actually, as I said, if you buy it, if it's not open source, it may cost you tens of thousands of dollars. Some of the open source, I like the open source tools a lot, and they do a lot of things. The problem with the open source is it needs a lot of time to set up. So one of the common tools is called Nagios, and it provides a complete network management system, or almost complete network management system that does a lot of things. It has a version of open source. It has been open source for a long time, but most recently they added a paid version of it. Of course, they jam it with a lot of features so you can go and buy it, but the core, a lot of organizations use just the open source to build big network management system. Another one is called Zabbix, also an open source network management platform that provides a lot of features, and some big organizations use the platform, and I'm gonna go show you. I didn't so here quickly the Zabbix and Nagios. Not a lot I can show you here. I used to run Zabbix in my network just for demonstration purposes, but I took it down. It consumed some resources in my small server here, so I took it down. But you can download it. It's free, open source. Zabbix is actually much easier to download and use than Nagios. Nagios takes a lot of effort. So if you have to choose which platform, you use Zabbix, my recommendation. But Nagios actually, it's a lot. I would say it's not a lot bigger, but it has been around for some time. It has a lot of components, and, and it does network management and network monitoring. So if I want to summarize all the network management system components, you'll see that for fault management, if I have an ideal network management system, it will be such one like here, what has polling, has alerts, has syslogs, server and traps. It has trouble ticket management. It has inventory management, configuration database, configuration auditing, network mapping, IP address, or VLAN management. By the way, these things can be done using Excel spreadsheets, right? So it depends on the size of the network. Accounting management, you need inventory and you need usage reporting. Performance, you need visualization, you need traffic analysis, you need historical trend analysis. For security, you need radius authentication or any other authentication service. You need log analysis. So not enough to do logs, but also you need some smart tools to do log analysis. And we talked in the security course about SIM. And then you need endpoint tracking, which is, checking or scanning the network to find if there are nodes coming in or removed from the network. Okay, so next we'll talk about licensing. So I mentioned open source a lot, but there are also a lot of software that's not open source, and some of them are famous and well known. One of them is SolarWinds. SolarWinds is one of those network management platform that is well known and it's not associated with any vendor, right? So there are a lot of vendors that have their own network management platforms that they sell, like Cisco, like HP. They have their own network management platforms. SolarWinds is one of the ones that doesn't have, or it's not uh, vendor neutral or vendor agnostic. And you can see here all the components that can be purchased for database management, network management, application management. So it's not just networking, but if you do networking, you see performance monitoring, traffic analyzer, IP address manager, IP monitor, log analyzer, syslog server, network automation manager. So all of these components. Right? Okay, uh, so what I mean by the licensing models. So that's how much you pay for the network management system. So it depends. Some software is sold by the number of nodes. So and they may be something like called freemium. So freemium is saying, okay, you can download this software and you can use it for a network as long as you don't have more than 99 devices to monitor. More than 99 devices, you have to pay, and you have to pay per the device. Like let's say from 100 to 1000, you pay this amount of money. From 1001 to 10,000, you pay this amount of money. So you pay by the number of nodes. Another licensing model is per interface. So per node sometimes is not fair. Let's say you have 5, 10 nodes, but each one of them will have fewer interfaces while somebody else have 5, 10 nodes, and each one of them has 24 ports, and you want to monitor all of them. So nodes sometimes is not an accurate measure of scale. So some vendors will sell you the software based on or charge you based on the number of interfaces that you want to monitor. So it doesn't matter how many nodes or how many devices, it's just how many interfaces. So you want to monitor 10 ports, fine. You want to monitor 100 ports, fine. You pay for that. Some even sell per sensor. So what I mean by per sensor, let's say you want to monitor 100 ports, but only you want to monitor one aspect, which is the bandwidth, right? So you want to monitor the bandwidth, which is in terms of SNMP, one object ID. You want to monitor one object ID. That's it, right? So you pay for 100 ports multiplied by the number of sensors you want to monitor. If you want to monitor the bandwidth, but also the CPU load for each device. So you add more sensors. So you have 10 devices. There are 10 CPU measurements for each. So you sell by sensor. So each one of them will be, sometimes it's not a choice. Some vendors use one licensing model, another um, use different licensing model. At the end, probably each one of the vendors will compete against the others because they are trying to um, appeal to certain customers. So if you have a really large network, a data center network, you may be looking for, I don't know, nodes, probably cheaper for you. If you have a small network, probably you'll ask, and you want to monitor a lot of things, that you may go for interfaces rather than sensors and so on. So that's for if you are talking about fault management and performance management. But some other aspects or some other tools doesn't really make sense to monitor or to pay per node or per ports. For example, log servers. It may not care about how many nodes, but it cares about the volume, um, how many entries in the server. So you pay by the volume. Configuration management, if you are dealing with 10 devices, you pay for 10 devices. If you are dealing with 100 devices, you pay 100 for 100 and so on. Collectors per interface, IP address manager per subnet. You manage multiple subnet, you pay per subnet. Topology visualization. Sometimes the software tells you that you can use this network map for only 10 devices, right? And if you want to have more, you pay more and so on. So we talked about network automation, and we want to talk now about one common or well-known network automation tool, which is Ansible. Ansible is open source, it's Python based, and we will use it in the lab to automate most of the work in the lab, right? So one aspect of network of Ansible that's appealing to to users is the fact that it's agentless, right? So what is agentless? So when we talked about network management, we talked about, having agent and a manager here, which is and agent here, right? And the protocol SNMP, for example, goes in between. Right? So this means that if I don't have an agent installed in the managed element here, the device, then I cannot manage it. Right? So if I want to use any network management protocol, I have to install an agent on the device that I need to manage. Even I can use SNMP, for example, to manage my servers, but I have to install a software on the managed server to be able to talk to it using SNMP. My printer has, in addition to all the software that allows it to print, has a SNMP agent that can speak SNMP and so on. So what is agentless? Agentless means that I don't really need to have an agent or a piece of software installed in the managed element to be able to manage it. So Ansible follows this principle. So Ansible can talk to a device without any specific software at the end. So it uses SSH to talk to the devices. Here we need to install the software, Ansible software, in the server. And that's it. That's all I need. Everything else that I don't need to install anything on the devices, which makes it appealing because that's all I need to do. I don't have to purchase specific devices that can talk Ansible or have software installed in them. I can just download Ansible in one of my machines here, and that's it. I can use it right away. So, and that's what's what we mean by agentless. Okay, so the Ansible architecture looks like this. We have something called control node, which is a machine that downloads or has the Ansible software. And because it's Python based, it can be installed on Linux or Windows or probably Mac as well, anywhere where Python can work. Okay? And then I can use it to um, talk to devices using SSH, which means it's a secure connection. Ansible needs at least two types of files. It may need more, but these are the minimum. Something called a playbook and something called inventory. Right? And before I continue talking about how Ansible works, I'll explain the idea behind Ansible. Right? So let's assume that we have the control node here, which is the server that we talked about. So I don't need to draw it again. It's here already. So, and as I said, it's based on Python. So because it's based on Python and Python is there on every device. So how Ansible works is by sending, so let's say I want to configure this server, right? This is a Linux server, and Linux servers have Python installed in them. So let's say I want to install piece of software here in the server. So I can send instructions, or Ansible send instructions to the server, the Linux server, telling it to run a specific Python code that allows the server to install software. I can also send it instructions to do anything they want, right? as long as there is Python code in there. Okay, so that means that we need Python to be installed in the server and the control node and the servers that being managed. Control node, sorry, not control node. Okay, but how about if I want to manage a router? A router doesn't run Python, so how can I manage a router? And I cannot install Python, and if I install Python, means that it's not agentless anymore, it's agentful, right? So how does Ansible control routers without installing anything? So as a matter of fact, what Ansible does, let's say I want to configure BGP. So Python, Ansible runs a specific Python code locally that does all the PGP configuration for the router, and then sends the command, like CLI command, to the router using on top of SSH. So SSH, or and then the CLI commands embedded in the messages, right? So the Python code that is needed to configure PGP is run locally on the control node. And what we send to the router is just the CLI commands that the router understands, right? So these are two ways to control devices. If the device understands Python, the control node will send instructions and ask the other end to run Python code locally. If the other end does not have Python, the Python code runs locally in the control node itself, and then the code will talk to the destination using its own understandable language. Okay? So that's how we manage all kind of network devices without needing to install anything on them. As I said, we need two files, the inventory file and the playbook file. So what is the inventory file? It's basically the list of all the devices that we need to manage, right? So the simplest thing is at the top here, where we have a list of IP addresses, just a simple IP address list, and that will be our inventory. So why do we need it anyways? We'll see that, well, if I am managing a network of many devices, some of them will be managed by Ansible, some of them will be managed by a different approach. So I'm just gonna list the devices that are managed by Ansible in this file. All right, this simple configuration here, it doesn't tell me the type of the device. And sometimes I need to configure switches, sometimes I need to configure routers, sometimes I need to configure Linux servers. So how can I manage all of that? So this is the bottom here, shows me a different architecture of the inventory file, where I have here two sets of routers. The first set called spine, and it has the name of the router in a human readable form, and then the IP address. Leaf routers has a list of the routers and their IP addresses, and you can tell here that this is an inventory file for a network that has a spine and leaf topology, right? Which is what we will use in the lab. So if I want to configure only the spine, I will indicate later that only the spine files, only the spine routers need to be configured. Okay, what if I want to configure everything? So here there's a third item that says routers. That's the name of the entire inventory, and I'm indicating that it has children spine and leaf. So this means that if I say configure all the routers, Ansible will understand that these two, the spine and leaf, are part of the all the routers, right? So it's a tree structure, basically. Ansible has two kind of configuration modes. One of them is using playbook, which is um, the elaborate way to configure things. But I can also use a single commands. So I can just say shut down all devices using a single command. We call these ad hoc commands. One of them is the format looks like this. Ansible all means all devices in the network. Dash M ping means ping all the devices, and then I am providing the inventory. So here means that all the devices in the inventory, ping them. The ping here is not ICMP ping. The ping is Ansible ping, which means it checks if I can reach that device using SSH and if that device can reply. Right? So the output or the reply will look like this: success, 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 or a failure if it doesn't reply. Right? Now these are quick commands that I can execute only occasionally, right? But if I want to do things more elaborate, then I have to write another file. It's called the playbook. The playbook is written in YAML, and YAML is a nice um, what's it called? Not a language exactly, but it's some people say it's yet another markup language, uh, but others say it means uh, YAML is or ain't a markup language. It depends on how you're interpreting it. But YAML, what's good about YAML is that you can take the YAML structure and convert it easily into JSON or um, Python dictionary, right? Or Python object. So it's very easy to configure between the two. So for example, when you see the dash, the three dashes means it's YAML at the top, and when you see dash here means it's a list item. So in this YAML file, we have a list of things. You can have a list of playbooks. This is only one in this case, and we have the name here. Create basic router configuration for INWK6912 Lab 1, and the hosts is the name of the host in the inventory. So we saw earlier that we have routers, so that includes all the hosts, and we have a connection, so we're using the CLI, and then we have certain variables, we'll talk about them, and then we have tasks. The tasks are list. So when you see tasks colon here means that this is a dictionary item, so the tasks is the key and the content is the list, and the list has each task has a name, and then we have the iOS config is called the module. Ansible has a lot of modules, so if I want to configure iOS device like a Cisco device, I'll use iOS config module. If I want to configure a Linux server, I'll use a different module. So these modules can be added the same way you can add there are modules for everything, so you can just write the name of the module. Some of them are built in, some of them you download them. And then here are the lines. So this is similar to the lines that you use to configure a router using the command line interface. So SNMP server community, and then this is a variable, and you will see that the variable is written here using Jinja format that you looked at in the programming course. So it acts the same way. So a task that enables SNP, a task that enables NTP, a task that enables syslog, and so on. Right? And then you can also tell that you can save the configuration after you're done, right? So you can do a lot of things here. Ansible, before I continue, Ansible works on the principle that if um, now I forgot what the name exactly, but it does not do things twice. So if you configure a router and it configures SNMP, NTP, and syslog, and then you apply the same playbook again, the router is not going to be configured again. Ansible is smart enough to check and say, okay, the configuration is there already, so it doesn't configure it again. Um, it is written here somewhere, or maybe in the notes that this has a specific name. Variables are used to remove the repetitive tasks from my Ansible configuration. So rather than put, for example, the port number here, I put it here, or actually there is a possibility that I can put the variables in a separate file altogether. So if I want to change the variable, the port number, for example, I can change it in one spot rather than going and change it in different spots. Same thing here, if I want to change the SNMP community string, I can change it here rather than change it in all places. So that allows me to do a lot of things much easier. So there is a lot of things that we can study in Ansible. We are not going to study all of the details. These are just basic things that we need to know in order to do the lab. These are some of the things that you can look at: Zabbix and OpenNMS. These are open source network management systems. So that concludes this lecture. There's a lot of things that we can talk about, but we probably need demos and hands-on to talk about them rather than just go over slides here. So that concludes actually the management part of the course, and in the next recordings we'll talk about design. See you then.